So this is your report sheet for this lab, and it's a little different format than we've had in the past. You'll get 2 points for completing the lab in Hayden McNeil, the simulation. 1 point for determining what the simplest formula of a compound is. And then we have our data. First, you'll need to mask the empty crucible, and then we'll describe what the copper looks like. You can double-click the crucible to see inside it. On this line here, you'll put the mass of the crucible and the copper that you added. And on the line below, you'll put the mass of the crucible and the oxide product. So the mass that goes on this line is after it's heated. Okay? Before it's heated, after it's heated. And then you'll want to describe the appearance of the oxide product. So that's our data. And then below, we'll do our calculations. 4A is the mass of the copper. Well, how do we know how much copper we have? Well, we have the mass up here of the crucible and the copper. That's on this line right here. If we subtract off the mass of the empty crucible, then we'll have the mass of the copper. That's what goes on this first line. The next line asks us the mass of the copper oxide product. Well, we can do sort of the same thing. On this line here, we have the mass of the crucible and the oxide product. If we subtract off the mass of the crucible, which is the first line, then we'll have the mass of just the product, just what's inside the crucible. Now the next one asks us what the mass of the oxygen is in the product. Well, how are you going to know that? Okay, so the mass of the oxygen was added. So we started with copper, and then on this line, we combined it with oxygen on 5A. So if we subtract 5, we take 5A and subtract off 4A, we'll get the mass of the oxygen that was added. So it's the difference in the mass of the copper and the copper oxide. Oxide just means we added oxygen. Okay, so now we've got the mass of the copper and the mass of the oxygen. We're in business. We need to know the moles of copper. And it's good if you could show your calculations here. You're going to use the molar mass of copper and determine the number of moles of copper. We need to know the moles of oxygen. So use the molar mass of oxygen from the periodic table to determine the moles of oxygen. Now, we're going to do a really cute trick. You're going to get weird numbers here. What we want is a whole number ratio. So the trick to get a whole number ratio is going to be to take the smallest of these two numbers and divide both of them by that number. And that's what we're doing here. So you put the moles of copper on the top, and then the smallest, either the moles of the copper or the mole of the oxygen, underneath. And we'll divide them, and then we should get a number that's close to a whole number. When we do that, all right? So we've got the moles on the top and the smallest number underneath. Moles of oxygen on the top, the smallest of those two numbers underneath. And this will give us our formula. We can use the moles of copper and put that here, the rounded moles of oxygen, and put that here, and that'll give us our formula. Then you've got some questions and problems to answer. Just work through them carefully and have a good time. Thanks for listening.